Okay, just looking to, I think I'll group all these videos for creating the arm itself into one, or at least close to it anyway. So I've just got a scrap piece of 3/8 inch plate here, and it has a slight bow to it. So this won't be the final jig. I just need something for right now to be able to, you know, lock the parts down too. So however I decide to do that, you know, with something here, then another block up here to hold this. Something down lower. Anyway, I just need something to work on. So this is just a, what is this? This is a 4.5 inch grinder from Harbor Freight. But I've got a nice heavy, God, it's probably about a 24 grit. Anyway, you gotta get the mill scale off if you want to actually weld to it. So I'm just cleaning it up real quick. I'm trying to keep it fairly flat because, you know, when you're out here on the edge like this, that abrasive on the outer edge there gets worn off pretty quick. But I still got quite a bit in the middle here. And this is sucked down in tight enough that it, you know, I'm not actually hitting that. So I'm trying to keep it nice and flat so I can use that abrasive on the middle, the inside of the disc. Close enough for that. Alright, this is the black pipe I was talking about. This is expensive DOM, 1/4 inch wall. Way overkill for, you know, the prototyping stuff. So this is just some cheap black pipe. This is actually a ladder rack off a 521 or something like that I got at one point. 1/8 inch wall, more than strong enough. This is actually strong enough to run on the final product, but I don't know that I'll do that. I haven't quite decided on dimensions yet. But basically I'm just going to chop this down to a different length and then get it cleaned up. And we'll chop it down here. This has got a hydraulic ram on it to assist with downfeed. So let's get it going. Feed. I don't need to cut this end off. I'm just doing it. Leaving this plugged in and using it. The belt jumps initially, I think, because of the it's slipping. Because it's got so much torque when it fires up. Belt tracks in and right back over, but Just looking to clean up the edges there a little bit. I was going to clean these up on the lathe, but I think I'm going to give it a try on the belt sander here first. Part of the design is to have this soft spot here, so let's see how it does at cleaning up pipe. As you can see, there's actually a lot of bumps running around the black pipe there. It's not near as smooth as DOM, so I think maybe just a clean-up cut on the lathe ought to do the trick. Alright, basically, I'm just going to chuck it into the lathe here, and I'm not worried about dimensional stability, anything like that. Hopefully it spins fairly true, and I don't have to cut too much off to get rid of it. Otherwise, it'd be good just to take a sander on here while it's spinning and just grind it off. So if it looks like I've got to cut too much off, I will probably pull out a sander and try that. Actually, I should just sand it with the emery paper and see how that goes. Well, let's see here. We can make a fairly come on, make a fairly fast cut here. Whoop, bump the camera. Alright, let's turn it over, and yeah, it got pretty warm, and we'll finish up the other side. I decided before I cut the last piece here, I thought, you know, maybe I should try the emery cloth and see how well it cleans that up. Because I did cut in so far, I will have to do a finishing cut, but I want to see how well it cleans the paint. Well, not near as nice as cutting it, but nice enough to weld too and that stuff. So I'll kick the RPMs up here a bit and check that too. Okay, that would have been good enough, but I'm going to go ahead and do the cut on it, cut it down to the same diameter as the other, but now I know, educational. Alright, basically I need to create a more or less temporary jig, okay, because this has the dimensions, you know, from the plate to the cross shaft set up on it, okay, but we're going to be using the 720 cross shaft, and it's not compatible with the ends on here, and I'm going to be using these ends and that stuff. So the actual fabrication jig will be quite a bit different, but I need a temporary jig to transfer these dimensions to. So basically what I'm going to do is I'm going to put a couple holes in here so I can bolt the plate down. I've got bolts with nuts underneath here. I'll weld the nuts to the tabs, and then I can take the bolts out and take this arm back off. Then I can put the plate down, and I can put a 720 cross shaft on here with these things in place. And then I can figure out the rest of it. So let's see here. We're going to use a transfer punch. You find the one that fits the closest in the hole there. That one's too big. So, okay, let's see. Hammer. Hammer. All right. I want to hold it, you can see how much that wiggles, okay? So you're just going to want to kind of get it as close to vertical as you can. And you don't, this is for marking, okay? You don't necessarily need to pound on that thing. You need to make a mark on there that's big enough to put a regular punch in. And that's about all you have to do. Now I could just leave this clamped and actually use that as a drill guide and drill down through there. That's quite tempting. But let's take a regular punch, find our transfer mark, and we'll give it a nice good whack. And that creates a hole big enough, a mushroomed area more or less, that the drill bit will be able to bite into easier. Because if you're a normal drill bit has, probably can't see this on the video, but a normal drill bit has a chisel point, and each side of that chisel point has to push the metal away. So a nice good heavy punch mark gives it kind of some meat there to start biting into. That way it doesn't just try to go against a flat surface and scoot around. So let me find all the stuff to drill the holes and go from there. Alright, let's see if we can drill a couple holes here. I've got them circled here with the punch marks. Now, with the vise here, basically I've opened the jaws up like that because that gives me a lot more stability. Okay, so that way when the drill's pushing in the middle here, I only have to keep it from rotating. I don't have to try to hold it flat. I don't need to open it up wide enough and clamp it because I want to be able to kind of float it around in that stuff. This piece is definitely big enough. I could hold this hard enough the drill bit would break, which wouldn't be good. But it's not that small that it's going to go ripping out of my hand or anything. So when so actually let's raise this back up. There we go. Okay. Yeah, I think it's still close enough. Okay, so what I'm also looking to do is in that punch mark, as you're looking down, I can see that as I just lightly touch down into the hole, the bit is flexing to the left there. Okay, so I'm going to kind of want to just wiggle that around until it drops into the punch mark without deflecting the drill anywhere. Okay. And this is just a pass-through hole, so I'm not worried about it being a perfect hole. If I was worried about that, I would have drilled this a couple sizes smaller and then taken a final pass that was much lighter cut. But in this case here, I'm just, I think I'll be fine. I'm just drilling straight through. It's, I don't remember what size bit it is, but a lot of times I'll use like an 1/8 inch drill bit as a pilot hole because I can get them in split point dirt cheap from Enco. And if you wear those out, whatever, no big deal, you just use another one. And that way you're not beating the hell out of your bigger, more expensive drill bits. Okay. Now, one advantage too, if I would have put it in the vise and clamped it and got everything lined up and that stuff, then I could have sprayed coolant or oil on or something like that while I was doing it. But you know, that's an old beater drill, but I'm really not too worried about it. It's fairly soft metal. Another reason not to worry about it too much. All right, I've got several drills. There's another one running around here somewhere too, I think. All Ryobi cordless. Anyway, I keep a countersink in one. I keep a screwdriver tip in another. The other one I use for drilling. So basically, once I've drilled a hole, I can just come over and grab the one with the countersink. And the countersink's getting a little dull. That's why I'm walking it around trying to eat the burr off. There we go. I just don't want a burr there to hold the bolt head up. Most of the burr is usually on the bottom anyway. Alright, that ought to do the trick. Okay, got the other holes drilled here, and I could bolt this together with pass-through and have nuts on the bottom side and stuff like that, but you know, it's really not going to add much more grief to just tap these holes, except for the fact that I drilled two and they were too big. The bolts that hold go into the ball joint are long enough. They're the right length. They'll sit right there. They'll go into the jig without poking through the bottom. So I can either use those or I can use these. These are 5/16 by something. 16 maybe? 14, 12, 13, I don't know. Anyway. Okay, so on the metric one, I know that I have an M8 by 1.25 tap. If you're looking for a tap, okay, simple drill gauge like this, 5/16. Okay, I knew it was 5/16 anyway, but if you got one of these, they're awesome. So next we'll go look up the tap size so we know what size to drill the hole. Okay, now I got this particular one offline, their website. They may still have it. I've had it up here for a few years now. Okay, so I'm going to be using the M8 by 1.25. That tells me the drill size is a 6.7 millimeter. There's actually 17/64 is the one I usually use. So let's look at that here. So M8, that says 6.7 millimeters. So let's go up here to decimal equivalent. Millimeters. Here we go. 2, 3, 6. I want 6.7. 6.75 is 17/64. Okay, so that's close enough. This isn't, I don't have to worry about precision. That's certainly going to give me enough drill thread engagement and all that kind of stuff. So that's perfectly fine. A 17/64 is a fairly common. Now, if you were doing the other one and doing the 5/16 18 that I had there, drill size F, I'm not exactly sure what F is. So let's look up here. F says it's 6.53 and it's 0.2570. So if you're going to tap it with that, you could actually use a 1/4 inch drill bit. It'd make your tap a little tight in there, but that way you could use a nice common 1/4 inch drill bit instead of, because there's a 7/1000ths difference. It'd be really tight on the tap, but it'd save you from having to go buy a F drill bit. Anyway, more boring information. Okay, I went ahead and re-drilled the holes. I'm going to tap them right now. I'll do one from back at an angle here and that stuff. So this, I've got a thread out there somewhere for the adapter I made and how I modified the tap attachment here, the tap holder. Usually that has a bar running through, so it's a T holder. These are 2 fluted spiral point gun taps made for using in power equipment. They're awesome. The spiral point flute pushes the chips through, so it's got to be a pass-through hole. I just did one recently with that before. Now, when you're tapping by hand here, you want to kind of pick your best line and get it as close to center as possible. The thing is it will to some extent try to self-center. So don't brace yourself against here so hard that it can't float up or down or left and right. You want to hold it and keep it from spinning. And as it starts to go through the hole, it will find its own path, and you'll feel it kind of center a little bit if you're off a little bit. So, and that's all there is to that one. Okay, and I think I probably have enough lubricant on for the next one. All right, perfect. Now I can bolt the part down and move on from there. Okay, so let's see if we got it lined up pretty close here. Oh, like butter. So yeah, there's a little bit of play there, but you know, on this particular jig, I'm not too worried about just exactly how close we are. It's proof of concept kind of thing. When it comes to the manufacturing one, the production jig and stuff like that, it'll be quite a bit different. So now I think what I'm going to do is, now that I've got that rigid, I can take these and see about, I got to cut this one down a little bit. So if I flip it over, my Sharpie went where? There we go. Okay. So it's got a clear, so I can flip it over here and mark where I want it cut. I'll cut or grind those down, and then I'll see if I can fire up the welder and just put a couple tacks on there to hold that stuff together, so that I can put the other cross shaft up there and have it in relation to that plate where I want it. All right, just want to run a couple of tacks in here. I think I've got everything set up okay. I'm going to tack the bottom there first so I can't push it over when I try to tack the bolts. So let's see here. Oh, it didn't even connect here. Yeah, there we go. Well, I can add some more once. I can add more once I take the thing out of the way, but I think it should hold for what I'm doing anyway. That's up. Oh yeah, hold. Okay. I think that does it for tacking the jig together for now. All right, I took the screws out. These bolts were quite hot. So there you have it. That should do the trick. Now, you know, that means that then this one will. The shit's still hot. I can set that up and put the bolts back in there, okay, with the collar, just like I had it on the frame jig. So that's just looking there just to see. But anyway, I'll have to pull this assembly apart to get the cross shaft out of it. So that'll be a separate set of videos, and possibly tomorrow. All right, it dawned on me that I was going to have to push these into here in order to set up the cross shaft, and I was like, wait a second. It dawned on me that I still had Bree 620's control arm here that has the aluminum bushings that I made just specifically for holding them, holding that cross shaft and everything on the other jig. This is the original arm. There's a build thread on Datsun. This was done for a different ball joint modification that pushed the whole spindle assembly out, the track width out 1.25 inches per side. Okay, but you can see that's what these pieces are for. Yeah, that one fits over there. Anyway, and same thing with the plate here and that stuff. So all the pieces that I've been playing with here, this is what they turned into for Bree. I never really needed the track width, so I didn't bother putting mine together, because I thought, well, I might need the pieces for something else. So I'm going to pull his apart just so I can get these bushings out and put them back together. A bunch of people have asked if he's looking to sell them, and his answer is always no. But anyway, so a washer per side here. We'll put that in. Oh, you know, something I need to do first. I need to chamfer the edges here. I'm laughing because I said chamfer the edges, and my buddy Dave called me on it, kind of thing. Anyway, I need to do that in the lathe first, or that's going to be a pain in the rear. You know, for then when I go to put it together when it's done or whatever. Except this is just a test one, so I really don't need to worry about it. Anyway, I'm going to go do that now, just in case I do end up using these pieces in the end. Okay, let's see. Washer on each side. Doesn't really matter which way these go. Okay, yes, the tolerance is pretty good on those. We'll put it back together with all the washers and the nut, just because that way I don't have to chase down parts. Okay, now this is loose here, but the aluminum is bushing is anchored down. Okay, so I just have to make sure that when I put the parts together in the jig and that stuff, that okay, they are bottomed out in the center and stuff like that. So now, hey, that's a lot cooler now. Not near as hot. Okay, this goes on. I've got these spacers made, and I think I need to clean up one of the holes, because they seem to only go in one way, kind of thing. So let's put these in real quick. I'm fading fast. I've been out here for like 2 whole hours, man. I'm about beat. Okay. I don't need them cranked down right now, but you know, you can see that that's holding everything pretty well where it's supposed to be. So let's take that. Take some of the debris and grit off. Where are they? There they are. There's that. There's that. Angle-wise, it looks like this thing might sit just a slight bit different flipped over. Not really. Maybe they're more symmetrical than I remembered. I know there was a bit of an angle before, but anyway, for just what we're looking at right now, I'm not going to worry about it too much. So anyway, this piece is well, that one could almost be salvaged. Now keep in mind that this bracket down here, this is going to go out, you know, and that piece will be more like out here. And this piece will get shortened and, you know, pointed down on top of here. So I think we're getting there. Basically what I'm going to do is I'm going to take the pipe, this is more than long enough, and I will see if I can figure out the angle, okay, and see if I can't do the fish mouth on this at the angle I need, kind of thing, and put that down there. Now, there's another idea that my buddy Dave and I are talking about, is the possibility of just having 3/8 inch laser cut 3/8 inch plate, okay, and it would come back here, and basically it would come out a little bit more, and then more straight back to the bushing collar here, okay, and then there'd be a 90-degree bend, and it would come up, and it would weld underneath here, and then I would have another 3/8 inch gusset laser cut out that would go from up here down to the vertical part of the arm, and then out to here. You know, it'd just be a big triangle, and a lot of it could get cut away. A lot of the mass could get taken away, but it would come out to here as a brace. So basically, that should make it at least as strong as any tubing butt welded up against here. So instead of doing a tubing arm, I may do it in laser cut, just because then the two pieces, I believe, if I do it right, the gusset for this side can also fit on this side. I'll just have to grind a bevel a little bit there to put it over at the angle here. So I'm going to play with that later. This is good enough for today.